Okay, today for our lesson 5 of our unit, we're looking at logarithmic expressions. They're actually probably brand new to you, other than possibly in grade 11, your teacher may have taught you something which was solving for x by taking the log of both sides. I don't know if anyone remembers that. If you don't worry. If you've never heard of that, don't worry. I'm going to teach you everything about logarithmic expressions today. And your main learning goal is that you can switch between logarithmic and exponential form. Okay, so we'll explain what that means on the next slide. So you have two different forms. You have logarithmic and you have exponential. Okay, so when you look at this, the only thing different is that between log and exponential form is that you have that extra log there. Okay, you write log, and it's actually like the opposite of doing what you're doing to an exponent. It's like undoing an exponent. Okay, so to find and switch between the two forms, really, it's kind of a memorization of what logarithmic form and exponential form look like, but it's easiest if you're going to label. So you notice you have a y on your left hand side of your log function. Well, that becomes your exponent. Okay, your subscript on b, just because it's below, it's not superscript, right? It's subscript, is going to be your base. And then your x here is going to become the left-hand side of your equation here. So you'll get used to going through them, and we'll practice that, and lots of homework will be on going between the two forms. Okay, so what we're going to do is change log of 9, log 9 of 3 equals 1/2 to exponential form. Okay, so to do that, you're best to label this and then write out exponential. Okay, so your left-hand side, or in this case, your right-hand side of your equation, that is going to be equal to y. Your log, and then that subscript is your b, and then the number beside that is your x. Okay, exponential form is x equals b to the exponent y. So your x is going to be 3. Your b is 9. And then you have a half there, okay? And it makes sense. What is the square root, or 9 to the exponent of half? The square root of 9 is 3, okay? So change 4 to the negative 3 equals 1 over 64 to logarithm form. So this is your example here. This would be x, your b, and then this is your y. So your form that you're going is y equals log b to the x, because you're going to logarithm form. So then that is going to be negative 3 is equal to log of 4 to the 1 all over 64. And I say brackets, put brackets there. So brackets aren't necessary, but it gets a little confusing if you just looked at this log 4 164 and you wrote it kind of messy and it's not, you're like, 464, where is that? So putting brackets around it just kind of keeps it a little bit nicer and neater. So I would recommend putting brackets just for your own sanity. Okay, so going back and forth between the two, I think your easiest way is to label the b, x, and y in your equation, and then write out the other form and just substitute that in. Okay, so lots and lots of practice in your homework on that. Okay, now what I want you to do is evaluate this. Okay, so you would have never evaluated this before. If you were to look at your calculator and say, ooh, I can plug that in, you do have a log button on your calculator, but you can't plug in the log of base 5 to the 625. Okay, you don't have the ability to do that on your calculator. So your easiest way to do that is to, sorry, I just want to write, can't plug, is to change it to exponential form. Okay, so what is exponential form? So you're going to get x is equal b to the y. Okay, and then this is equal to your b, and this is equal to your y. We just don't have an x in this one. Sorry, this is your x. Sorry, we don't have a y. Okay, you don't have a y equals here. Okay, so then what you're going to do, so take your x of 625, plug in your b as 5. And then you're going to solve this for y. Well, I just taught you 2 lessons ago how to solve this. So change 625 to a base of 5. So 625 as a base of 5 is 5 to the exponent 4 is equal to 5 to the y. Now, set your exponents equal to each other because you have the same base. So 4 is equal to y. Okay, so that is how you would solve this or evaluate this question. So your answer would be 4. Okay, for this one, log of 3 over 4 bracket 27 divided by 64 bracket. Okay, so again, your easiest to go b, and then this is your x. Okay, then you're going to substitute that into your exponential form equation. So your x is 27 all over 64 is equal to 3 all over 4 to the y. Okay, so what you can do is think of how can you change 27 to base 3? Well, that's 3 to the exponent 3. How can you change 64 to the base 4? Well, that is 4 to the 3. Okay, so then you have that is equal to this still. Okay, now it's probably easier. You have the same exponent, so write this as 3 to the 4 all to the 3. You have the exact same bases, okay, 3 to the 4, so set your exponents equal to each other. So your answer is 3 for this example. Okay, so a little tricky there, but it's just going from log form to exponential form, and then from exponential form, you already know how to solve questions like that. Okay, so another example is if you were given something like this. So log 10. Well, before I was showing you something like log 6 of 15, or well, I don't know, let's go log 8 of 10, or whatever it is. You saw both that subscript and the number beside it. So when you're solving something like this and you see just log 10, this where's this communication tip comes in handy. So it says if there's no value a in a logarithmic function, so that value a here, the base is understood to be 10. So that is log x is equal to log 10x. Logarithms with base 10 are called common logarithms. Okay, so they're called the common logarithms. So if you were to solve a, this is actually like saying log base 10 of 10. Okay, you can plug this in your calculator. You don't plug log 10 of 10 in, okay? So try plugging log 10 in your calculator. You should get an answer of 1, okay? For B, it's the same thing. Log 10 of 100, you should get an answer of 2, because it's figuring out what exponent of 10 equals 100. Well, 100 to exponent 2 is 100. Okay, this next one, log, it would be 10 of 500 is equal to, and if you plug that in your log of 500 into your calculator, you'll get a number between, because 10 to the exponent 3 would be 1,000, so you're getting halfway in between that 2 and that 3, or a little bit more than halfway, so you get approximately 2.7 when you plug in log of 500 into your calculator. Okay, so the big thing here is that any log x is understood to be log of 10x, so with that base of 10. Okay, so just keep that in mind there. That's your key learning from this slide. Okay, so another example. Oops, that just went over what I just did. Okay, so another example, so log 1 over 100, that is like saying log 10 of 1 over 100, or you could plug in log of 1 over 100 on your calculator, but you should get you're asking yourself, what to the exponent 10 is equal to 1 all over 100? Well, it is -2, right? Because of your exponent rules, 10 to the -2 is equal to 1 all over 100. So you should know that answer is going to be -2. Remember, it's you're kind of reversing and undoing an exponential with logarithms. Okay, so let's go through a couple more examples here. So this one, you're simply just plugging this in on your calculator. So log of 35, plug it in on your calculator. It's 1.54 is equal to x, or approximately. Okay, this one here is log of 10. 64 is 2, right? So it's understood to be, sorry, not what I was trying to do. Sorry. I looked at another example and confused myself. Okay, so this one is like you're saying what in exponential form. So x, the base, becomes your base here. Your answer is your exponent, and then is equal, your number here is your answer. So that's just going to exponential form. Okay, and then you're going to just figure out x by taking the square root. So x is equal to 8. So if you did log 8 of 64 is equal to 2, and we solved it exponentially, you would get an answer of x equals 8. Okay, this example here, log 9 of 100 is equal to x. Well, you're going to get 9x is equal to 100, just putting it in an exponential form. Okay, then the way that I would teach you this is either, last year you would have used guess and check for this, or you can do something what we called, and I showed my students last year, but it's called taking the log of both sides. So it's really easy. So all you're going to do is write log of 9, and then the x comes out front, okay? And then take the log of 100. So you've taken the log of both sides. Then you're going to divide by the log of 9 on both sides because you want that x by itself. So then these cancel out. You have an x, and you're just going to simply type in the log of 100 on your calculator divided by the log of 9 on your calculator, and you should get approximately let's round to 2.1. Okay, so this is something called taking the log of both sides. It's really easy. It's the same thing each time, but that's how you would evaluate something like that. Okay, two more examples here. So use reasoning to evaluate logarithmic expression. So log base 3 of 1 over 27. Okay, so what you're going to do here is put in exponential form. So when you put that in exponential form, it is going to become 3 to the exponent x equals 1 over 27. Okay, then you're going to evaluate just like we did. So get 27 as a base of 3. So it's 3 to the 3, but because it's in the denominator, it needs to be -3. You have your exponents equal to the same thing, so x is equal to -3. Okay, so that's an example that you can do that. Or from here, you could also take the log of both sides. So what you would do here is you'd go x log 3 is equal to the log of 1 all over 27, and then divide that by log 3, divide by log 3. So x is equal to, and then if you did that on your calculator, you should get an answer of -3. Okay, so you can do this one way or another way. It's up to you. Okay, for this one, you have log 2 to the -4. Well, we're figuring out 2 to what exponent is equal to -4. Well, if you were to write this in exponential form, you're figuring 2 to what exponent equals -4. There is no answer. Okay, because if you're looking at 2 to the x, here's your graph of 2 to the x. Well, you're trying to figure out where it's going to equal -4. So where is it going to come down here? It's never going to get there. It has that asymptote at y equals 0. It's never going to go below and equal -4. Okay, so that is why that there's no solution. You couldn't figure this out. If you take the log of, let's do this, x log of 2 is equal to the log of -4, divide by log of 2. So say that you're taking the log of both sides. If you take the log of -4, you're going to keep getting error. Okay, so it doesn't work, therefore there is no solution. Okay, so lots and lots of examples to work on for your homework here. Let me know if you have any questions. I can help you. These are totally new, so hopefully you do have some questions for me. You can email me or ask me during our lessons. Okay, good luck.